14C, and it sucks. C. Hear that, people? It sucks. 14C.
14C is what it is.
I do little bits of it.
Family show.
It's alright. Little bits of it. Alright. So, finding the sample size. So, what we're going to do is a couple of, just one example, that's all there is today. So you've got plenty of work time. Alright, text page 608. Example 8.
So originally what was it?
Alright, it says that the probability of winning a prize in a game of chance is 0.48. So, probability of a prize is equal to 0.48. So, what we're doing is, we're doing in the binomial, of course. So, what that means is that P, probability of success, is 0.48. So then what we're asked to do is a couple of things. So first of all, it says what is the least number of games that must be played to ensure the probability of winning at least once is more than 0.95. So let's have a look at what A is asking. So A is asking what's the least number of games, so how many games have you got to play? So the probability of winning at least one, so that's greater than or equal to 1. Remember when we are writing these ones down, we want to use the equals as well, because that's sort of our calculator, how it's programmed. So greater than or equal to 1, we want that to be more than 0.95. All right. So let's have a look, work with this. So if this is the probability x greater than or equal to 1, now because we don't know where that upper limit is, we don't know how many games it is that we're going to play, we're not going to be able to use our calculator. Just remember when we used our calculator, it comes up with that green that wants to know what our lower and upper limits are. So what we've got to do is write it in terms of less than. So greater than or equal to 1 is the same as 1 minus the probability that x is less than 1. And again, the calculator less than 1, remembering that this is binomial, there's only one option that's less than 1, and that's 0. So that is that. All right. So we need to rearrange this so that we get probability of x equals 0. So if we take 1 from both sides, then we're looking at negative probability of x equals 0 to be greater than negative 0.05. This negative's here, so we can divide by negative 1. Now when we divide by a negative, we must remember to change the sign. So we're looking at the probability that x is equal to 0 to be less than 0.5. All right. So the probability that x equals 0 is n above 0 times 0.48 to the 0. Just remember, probability of x equals little x is n above x p to the x cube to the n minus x. And so q is 0.52 to the power of n minus 0, which is just n. N above 0, anything that's above 0, doesn't matter how many things, choosing none, there's only one way you can choose none, and that's not to choose anything. Correct, Lara?
That was the most confusing part.
So, we've got n things, we're not choosing any. How many different ways can you do that?
None.
One, by not choosing. Alright, so 1, anything to the power of 0?
Wait, why is it 1? I thought you said none.
No, there's one.
One option that's not choosing.
And one option, that's not
There's
choosing.
one-
Not choosing
there's a-
counts as an option.
Yeah, la. There's
Yeah.
only one way to get nothing.
Not choosing is an option.
Oh,
yes.
so 1 way. Yeah. Sorry, keep going.
But the only way to win is to
This
not
is like some
choose.
philosophy.
Not choose that option.
Alright.
The line.
So that's just
It's
0.52
not choosing.
to the n. Right, so let's write from here, we'll write a note. So n above 0, there's one way of not choosing. That is, don't select anything.
Sounds like queer talk.
Alright, so that's a handy thing to know.
Set up time.
Yeah, no.
That's a problem.
I was looking at Just keep going, don't worry.
Picking on me. Alright, so what do we got? So we've got the probability x equals 0 to be 0.52 to the n. Up here we wanted that probability x equals 0 to be less than 0.5. So what we want then is 0.52 to the n is less than 0.05, and then we go to our calculator, use the solve function.
0.05.
It is correct. And so we go calculator, solve. 0.52 to the power of n. We need to be less than, going to go to our keyboard, less than 0.05. Find n for me. And there it is. So when we do that, it tells us that n has got to be greater than 4.58, 11, whatever, blah, blah, blah. Now,
Rounds to 5.
round it to
5.
5, yep. And so we need to round it to 5 because we can't have 0.58 of a trial. You either got a whole trial or you've got no trials. It's like it's dice, for example. You throw the dice or you don't. So you can only have whole numbers.
This is just
So the question asks what's the least number of games. So the least number of games is 5.
why is it not 4? Because you have to round up. Because it needs to be more than 4. I think. And also, either way you round that.
Yeah, you can't have a fraction of a trial. So you can't play a fraction of a game. You've got to either play the game or not.
And if it was 4.5,
So
it still have to be 5.
yeah.
Because
Right, because the question says you
it
want
must be
greater than 0.95. So to be greater than 0.95, it's got to be greater than this. So if it was the answer, as Nicole said, if the answer came out to be 4.1, well, 4.1 is when it equals 0.95. So if you go down to 4, it's going to be less than that. And we want it to be greater than that. So in this case, you're always going up.
Always go up.
Because if you want the probability to be greater than that, well, if you do more trials, it's going to be greater than that. Alright, part B. Second part of the game. Part B says, what's the least number of games that must be played to ensure the probability of winning at least twice? So it changes it slightly. And so n, again, we don't know. But we know the probability of winning is 0.48. So of course the probability of losing, which we've already used, is 0.52. And where am I? What do we want? We want probability of winning at least twice. So the probability that x is greater than or equal to 2 to be more than 0.95. All right. So again, if we look at the same kind of adjustment, again, we don't know what that upper limit is, so we can't use the calculator and that binomial thing where, you know, it had, I'll bring it up here, where are we? That's not the one I want, interactive one. All right, so it wants a lower limit and an upper limit, and so we don't know what that is, so that's why we can't use that particular thing in that way. There is another way you can use it, but we won't worry about that at the moment. So we're looking at 1 minus the probability that x is less than 2 to be greater than 0.95. So if I rearrange that, same as I did before, by taking 1 and then dividing by -1, I'll get that. Now, probability x is less than 2 is probability that x equals 0 plus the probability that x equals 1. And we want that to be less than 0.5. So what are these things? Well, the first one here is exactly what we had before. It's n trials, don't know wins, times 0.48 to the 0 times 0.52 to the n. When x is equal to 1, so n trials, 1 win, 0.48 to the 1 times 0.52 to the n minus 1, and we want that to be less than 0.05. Right, this bit we worked out before. There's one way of doing that. That's 1, so we've got 0.52 to the n. Now, if we've got n things and we're selecting 1, how many different ways could we do that?
1, 2,
Okay, let's say I've got
5.
5 things, all right? I've
I
got
just
5
said
things.
5.
There they are. My 5 things. There they are. 1, 2, 3, 4, 5. How many different ways could I select 1 out of this group of 5?
5.
5. So it's n. N times 0.48.
Yeah, why's it n?
Because you want one of the n.
Yeah, one of the however many you've got. So if I add
Okay.
10 in there,
Alright.
and I take 1, there's 10 different ways I could select that 1. Alright, and I want this to be, less than 0.05. Alright, let's stick that in the calculator and see what we get. Right, so I don't want that one. Let's get rid of my keyboard. Let's clear that stuff. Alright, so I want to solve. I want to solve 0.52 to the n to the power of n plus n times 0.48 times 0.52 to the power of
That's an A.
0.82.
thanks to the power of n minus 1, and I want that to be less than 0.05. Give me n, please. And we get something that doesn't look very nice at all. The question is, how can we get around that? Well, if we
Can't get around it.
well, we can. Oh, come on. There we go. Come on. I want all of that. If I...
I don't think you got the whole
No, I
thing.
didn't get the whole bit. 0.05. Give me x. If I change this less than to equals, and then ask it to solve, more solutions may exist.
Ew.
Let's not worry about the more solutions may exist. Well, what do you know about that number? It's not going to be any good to us, is it? Then we've got 7.7985. And then it says more solutions may exist, but the question says, what's the question say? It says what is the
Minimum.
least number of games? So it doesn't really matter if there's any more solutions. We've got 7.7985. And so on. But what do we got to remember?
8.
8, yeah. Because you either have a win or you don't have a win. You can't have part of a win. Alright, so the least number of games is 8. Now you've got to play at least 8.
How come changing it to an equals doesn't change anything?
Because the function is a more complicated function than before, and so the calculator can't cope with that calculation. So it just gives it to you in a factorised form of what you already put up there. So change it to an equals and it tells you where it's going to equal point. It will tell you where it's going to equal that. And then if we know when we can equal that, then we know for it to be less than that, then we've got to play more games. Now there is another way of doing it using the graphs and tables, and I've got a sheet that I will give you that runs through that one. All right.
Do you have to know how to do it both ways?
Probably a good idea, yes. Is it essential? Probably not. But you can stick that in your band reference, can't you? So you've got both. All right. So yeah, something like this. Finding the sample size, pretty unlikely it's going to be
It's not that hot.
See, it's 13 degrees.
It's
Without
cold.
calculator.
I'm
Wait,
sweating.
No, it's warmer than 13 degrees in here. No, just keep
14C.
Stop that.